Hello, and welcome to the 7th Annual AAKP Global Summit on Kidney Disease Innovations, themed The Decade of the Kidney at Midpoint: Opportunities and Barriers to Greater Innovation and Freedom from Disease and Disability. This annual event is proudly hosted by the American Association of Kidney Patients in collaboration with our allied partners at George Washington School of Medicine and Health Sciences. My name is Carl Juresic, and I'm honored to serve as the AAKP International Ambassador from Australia, and I'm also a kidney transplant patient. I was diagnosed as a teenager with kidney issues caused by a severe case of HSP and vasculitis, which ultimately led to a kidney transplant when I was 25, 13 years ago. I work as a strategist across APAC, based in Sydney for Uber, but also serve as the founder and CEO of Kidney Ally, a startup dedicated to helping patients self-manage chronic kidney disease. Being involved in AAKP allows me, as a patient, to be part of a global kidney community committed to improving the lives of kidney patients. It has empowered me to use my personal journey and professional skills to advocate for innovation, education, and patient-led solutions in kidney care. Since 2019, the Global Summit has served the global kidney community as the largest patient-led kidney disease innovation summit in the world. This year's Global Summit marks an important milestone because it is the midpoint of the AAKP-led Decade of the Kidney. This global initiative has been mirrored across the world by kidney advocates, medical allies, and government officials, and among people of goodwill committed to the return of the true patient-centered medicine. Throughout the first half of the Decade of the Kidney, we have raised awareness about the increasing burdens of kidney disease worldwide among people, communities, workforces, and governments. This effort has also accelerated a golden era of medicine and the determination to transcend the status quo in treatments, including brick-and-mortar dialysis, to a future kidney care that will be determined by expansions in patient consumer care choice, targeted therapies that stop kidney disease and prevent kidney failure, greater access to donated organs, new devices and alternatives to human organs, including an artificial wearable and implantable kidneys and xenotransplantation. We believe the time is now as we move through the next 5 years for patients, care partners, clinicians, researchers, innovators, industry, and government leaders to accelerate our bold actions to push forward modern diagnostics, devices, and therapeutics and continue to remove outdated policies that block their adoption. No country is immune to the impacts of kidney disease, but the good news is every person watching has a role in shaping a future for all people who are at risk or living with kidney disease and offer more hope, better outcomes, and greater independence and freedom from kidney disease and disability. With that, I am honored to serve as the moderator for our session titled Important Early Intervention Studies of Kidney Diseases. First, it's my pleasure to introduce Dr. Akhtar Ashfaq, the Senior Vice President of Clinical Research and Development at OPKO Pharmaceuticals. Dr. Ashfaq has over 15 years of clinical experience and is leading the development of innovative treatments for chronic kidney disease, including Rayaldee and Alpharin. Previously, Dr. Ashfaq had senior roles at AstraZeneca and Amgen, including a focus on CKD therapies. His expertise in early intervention studies is invaluable, and today he will share insights on critical research aimed at improving outcomes for CKD patients. Please join me in welcoming Dr. Ashfaq.
Thank you so much, Carl, and thank you, American Association of Kidney Patients and George Washington University for this opportunity. Today, the topic of my presentation is advancement in the treatment of secondary hyperparathyroidism in chronic kidney disease. My disclosure, I am a full-time employee of OPKO Pharmaceuticals and also serves as voluntary faculty at the University of Miami. I'm also a past member of the Medical Advisory Board of American Association of Kidney Patients. This is the indication for Rayaldee, the drug which I'm going to be discussing today. Rayaldee, which is extended-release calcifediol, is indicated for the treatment of secondary hyperparathyroidism in adults with stage 3 or 4 chronic kidney disease and serum total 25-hydroxy vitamin D levels less than 30 nanograms per ml. Rayaldee is not indicated in patients with stage 5 chronic kidney disease or end-stage renal disease patients on dialysis. This is a brief overview of my presentation. Before diving into this, just wanted to share some high-level epidemiology with you on chronic kidney disease. Chronic kidney disease is actually a global crisis. More than 850 million people affected by chronic kidney disease globally. Just in the United States, it is estimated that 35.5 million patients have chronic kidney disease, out of which 18.2 million US adults have stage 3 or 4 chronic kidney disease. 34% of these chronic kidney disease patients are 65 years or older. It is seen more in African Americans, and approximately 90% of people with chronic kidney disease go undiagnosed. A paper from 2018 showed chronic kidney disease as number 16 on the top 200 list in terms of mortality. And it is estimated that by 2040, that number will climb from number 16 to number 5, only below ischemic heart disease, stroke, lower respiratory infections, and chronic obstructive lung disease. And this certainly needs attention, and this has got to change. Now, there are many diseases which bring patients to chronic kidney disease, including diabetes, hypertension, obesity, glomerulonephritis, etc. But once a patient develops chronic kidney disease, as you can see from this slide, everybody is going to get secondary hyperparathyroidism. Secondary hyperparathyroidism is a major complication of chronic kidney disease. As the kidney disease progresses, its severity increases. Vitamin D insufficiency is a key driver of secondary hyperparathyroidism and can be readily corrected with appropriate treatment. Early and effective treatment of secondary hyperparathyroidism preserves bone health, reduces the risk of vascular calcification, and may also slow down the progression of kidney disease. Unfortunately, most patients with stage 3 or 4 chronic kidney disease are not evaluated for elevated intact parathyroid hormone levels or vitamin D insufficiency. Now, a brief overview of vitamin D metabolism in patients with normal kidney function. The sun is a great source of vitamin D. The rays of sun falls on skin and converts the pre-vitamin D or pre-cholecalciferol into vitamin D3. When there is not enough sun available, there are other sources of vitamin D, including nutritional vitamin D supplements, which include D2 or D3. D2 is ergocalciferol, D3 is cholecalciferol. D2 is plant-based vitamin D, cholecalciferol is animal-based vitamin D. This D2 or D3 then has to go to liver to be converted into 25 hydroxy vitamin D in the presence of 25 hydroxylase. And this 25 hydroxy vitamin D then has to go to kidney to become active vitamin D hormone. Active vitamin D plays a critical role in maintaining calcium and phosphorus homeostasis, essential for bone health and various cellular functions. Now, what happened with secondary hyperparathyroidism? As you may know, the D2 and D3, ergocalciferol or cholecalciferol, are very lipophilic. They are bound to chylomicrons, and as patients with chronic kidney disease who are relatively more overweight or obese, instead of taking this D2 or D3 to liver, a lot of that D2 or D3 is actually siphoned to adipose tissue, and it just gets sequestered there and doesn't come out into circulation. So very little D2 or D3 actually gets to the liver. Whatever D2 or D3 gets to the liver, and the liver has to convert into 25 hydroxy vitamin D. But obesity and diabetes also inhibit or downregulate the expression of 25 hydroxylase. So even if the D2 or D3 can get to liver, it does not get converted to 25 hydroxy vitamin D. Now, this 25 hydroxy vitamin D has to go to kidney to become active vitamin D hormone. 1-alpha hydroxylase activity, which is the hormone which is present in the kidney, which converts the 25 to 125, is reduced by rising FGF23 levels, serum phosphorus level, and loss of functioning kidney tissue. So, in other words, elevated PTH is nephrotoxic. How do we know that? There are about 8 different studies which have been published since 2008, which have talked about the relationship of high PTH and either mortality or worsening in the kidney function. The pathophysiology of elevated PTH in terms of nephrotoxicity is through increases in intrarenal calcium deposition, induces oxidative stress and inflammation. It causes direct podocyte and tubular damage. It enhances RAS activation and hypertension, worse bone mineral disorder, promotes renal fibrosis, and may also make the anemia of chronic kidney disease worse. Vitamin D plays a critical role in preventing and managing secondary hyperparathyroidism in patients with chronic kidney disease by regulating PTH, calcium, and phosphorus balance. We talked a little bit about the vitamin D based therapies, including the nutritional vitamin D supplements, but the other therapy which is now becoming more available is calcifediol, and we are going to talk a little bit about it further in the presentation. And the last one, which is everybody knows well, is the active vitamin D and vitamin D analogs. Vitamin D supplements and active vitamin D may not be appropriate for secondary hyperparathyroidism treatment in stages 3 or 4 chronic kidney disease. Why? Because nutritional vitamin D supplements have limited ability to correct vitamin D insufficiency, and this even gets worse in patients with obesity or progressive kidney disease. Nutritional vitamin Ds are also not approved by FDA for secondary hyperparathyroidism. And even though nutritional vitamin Ds are available for at least 30 years, according to KDIGO, their effectiveness is unproven. On the other hand, active vitamin D or active vitamin E analogs are unable to correct vitamin D insufficiency. They are good drugs in lowering PTH, but they increase serum phosphorus and FGF23. And they also increase the risk of hypercalcemia and vascular calcification. And as you know, vascular calcification is probably one of the leading causes of morbidity and mortality in patients with chronic kidney disease. And therefore, KDIGO has made a statement in 2017 guideline update where they mentioned that routine use of activated vitamin D analogs should be avoided in non-dialysis patients. So there is an urgent unmet medical need for safer and more effective therapies of secondary hyperparathyroidism in CKD. So calcifediol in stage 3 and stage 4 CKD. Rayaldee is the extended release calcifediol. It's indicated for stage 3 and 4 CKD patients who have secondary hyperparathyroidism and vitamin D insufficiency. Its efficacy has been proven in multiple randomized clinical trials. It is safe and does not raise serum calcium or phosphorus as FGF23. It is the only FDA-approved extended release vitamin D3 prohormone. It comes in once daily capsule where the calcifediol actually released from the capsule over 12 hours. The mechanism of action of Rayaldee. Rayaldee slowly, reliably, and very predictably increases serum 25D levels to high levels. This increase in 25D leads to increase in 125D, but because of the limited capacity of the diseased kidney, not all the 25D is activated to active vitamin D hormone. But because of serum 25D levels, which can be raised significantly high with the use of extended release calcifediol or Rayaldee, by engaging extrarenal 1-alpha hydroxylase, that can convert into 125D, which acts locally in an autocrine or paracrine manner. And this 125D increase by the extrarenal 1-alpha hydroxylase can lead to decrease in PTH synthesis and secretion, maintains bone and mineral hemostasis, and normal in calcium phosphorus absorption. Just review quickly the phase 3 trial on the basis of which extended release calcifediol or Rayaldee was approved. The trial was active versus placebo, 26 weeks duration, 2 different trials under the same umbrella, enrolled 429 patients with stage 3 or 4 chronic kidney disease with SHPT and vitamin D insufficiency. These 2 trials were followed by an open label extension of another 26 weeks. So patients who stayed on Rayaldee for 26 weeks and continued on the open label extension actually had 1-year exposure. And I'm going to share some interesting data with you. The red line you see at the bottom is the 25D level of the placebo patients who were treated with placebo over the course of 26 weeks in this blinded study. The blue line, which you see above, which is slowly, gradually, predictably increasing, is the line of patients who received active drug that's extended release calcifidiol. And you could see by the end of the 26-week blinded study period, the 25D had risen to 69 nanogram per ml, and the 25D level in patients with placebo treatment remained unchanged. At the end of 26 weeks, patients who were receiving placebo were allowed to get into the active arm, and they also received Rayaldee. And you could see on the extreme right side of the slide that patients who received now active drug were also able to reach almost to the same magnitude as the people who were getting, or the patients who were getting Rayaldee from the very beginning. So at the end of the 52-week treatment period, the mean 25D level had risen from 19 nanograms to 79 nanograms per ml. This slide is the most important slide from my perspective, which shows that Rayaldee actually was able to lower the PTH significantly in patients who were treated with the active drug over this 26-week and then further into the open label extension. But what is more important to me is the red line, which you're seeing above. And that shows that patients who were given placebo, within just this 26-week period, you could see a certain increase in their PTH levels. So for the folks who do not know at what time they engage in treating these patients with secondary hyperparathyroidism, it doesn't matter what PTH level they have, they know that the PTH level is going to continue to rise until they actually treat them. So no matter what level they pick the patient is going to get benefit from treatment of secondary hyperparathyroidism. This is now one of the most important concepts of this presentation, and that is that it doesn't matter how high you raise the 25D level using extended release calcifidiol. Either you are in the first line on the left side, first bar on the left side, where the end of the treatment 25D level was 13.9, or you're on the extreme right side, where the 25D levels rose to 92.5, you could see that there is absolutely no change, no significant change in serum calcium, no significant change in serum phosphorus, and no significant change in FGF23. That talks about the safety of this product. No significant changes in serum calcium, phosphorus, and FGF23 between different levels of 25D level were seen after 26 weeks of treatment. The next slide actually is more important from the perspective that Rayaldee, unlike nutritional vitamin D, for example, can lower the PTH at any given PTH level, and it doesn't matter what stage of CKD you are. So this is a slide from the phase 3 trial where it shows that Rayaldee raised the 25D level and lowered the PTH exactly the same in stage 3 as in stage 4 CKD. In other words, Rayaldee does not require active kidney function to lower the PTH. And this is the third most important concept. And we all talk about vitamin D insufficiency and deficiency, and there is huge debate in terms of what is the sufficient level, what is the insufficient level. In this post hoc analysis we published in 2019, we for the first time actually were able to show that you need to take the 25D levels to 50 nanogram or higher to effectively lower PTH. And what do I mean by effective lowering of PTH is that the lowering of PTH by 30% or more from baseline. By the way, this endpoint has been used in many other drug development trials and is a favorite FDA endpoint in terms of drug approvals. And as you can see in this slide, that unless you are able to raise the 25D level above 50, you are not going to be able to start lowering the PTH effectively. So the question is, what should be the sufficient level in patients with chronic kidney disease? That has not been discovered as of yet. We don't know what the correct level is, but we from our data have shown that the level at least have to be above 50 nanograms to effectively lower PTH. People forget that in patients with chronic kidney disease, repleting a deficiency is not the only primary goal. The primary function of using vitamin D is not just to raise the 25D level, but to raise the level to a point where you can meaningfully lower the PTH. And as I've been saying the same thing again and again, that the magic number is upward of 50 nanograms per ml. This is one of the studies we published in 2023, where we looked at 4 different drugs. We used pericalcitol and a combination of pericalcitol and cholecalciferol and compared it with the immediate release calcifediol, cholecalciferol, or Rayaldee. And as you can see, the only drug which was able to raise the 25D level above 50 was Rayaldee. None of the other 3 drugs, including the reference drug, was able to raise the 25D level above 30. And we always talk about this, that if you cannot raise the 25D level, you probably are not going to be able to lower the PTH. On the left side of this slide, you could see we used, in the cholecalciferol arm, we used 300,000 international units of cholecalciferol, and even that dose could not raise the 25D levels of any of the patients in the chole arm above 50. On the other hand, if you look at the Rayaldee, which is in the above boxed part of the slide, Rayaldee was able to raise the 25D level in the most obese patients effectively. Now, what does that mean? Lowering the PTH is important because we all know that high PTH is nephrotoxic, but nobody has ever shown that if you lower the PTH, you're going to actually get any benefit. For the first time, we did a post hoc analysis and we published this data in 2024. We looked at 126 adult patients with stage 3 or 4 CKD, secondary hyperparathyroidism, and vitamin D insufficiency. They were all treated with Rayaldee for 1 year at a dose of 30, raising to 60 micrograms as needed. And the endpoint was 30% or more reduction in PTH in last 2 quarters or the last 6 months of this 1-year study. So 75 of those patients who were included in this analysis did not get to 30% or lower reduction in PTH. So the PTH reduction was not sustained in the last 2 quarters. 51 patients in this trial were able to get their PTH below 30% or lower than 30% and were able to keep the PTH at that level. What does that show? On the left side, you could see the 25D levels in the group which had the 30% or more sustained reduction in PTH. The mean 25D level in those 51 patients was 89.1 nanograms per ml. And on the left side of this figure, you could see that the patients who did not get a sustained lowering of PTH in the last 2 quarters, and the N was 75, their mean 25D levels was 72.1. Now look at the right side of the graph of this slide, and you could see in those patients who were able to lower their PTH and kept their PTH below 30% for the last 2 quarters had a reduction in their GFR by 0.6 cc, as compared to the group which was not able to sustain the PTH 30% or more. Their decline in GFR was 3.2 cc, significant reduction in their GFRs if they are not able to lower their PTH more than 30% and keep it there. And the question is this all or none? No, that's not actually the case. Those patients who were able to lower the PTH, but not up to 30%, had some reduction, but not as much reduction in their GFR, as compared to the group which had absolutely no reduction in their PTH. And those are the 21 patients who had no reduction in PTH, and their decline in GFR was 22%. So the take-home message from this analysis was that if you lower the PTH by 30% or more from the baseline and keep it sustained at a low level, more than 30% for 2 quarters, you actually can slow down the progression of kidney disease. And this has never been shown this before. So the obvious next question could have been that if the lowering of PTH is the ultimate goal, then why do I have to use extended release calcifediol or Rayaldee? Why could not I just use activated vitamin D analogs? And we ran a prospective randomized clinical trial in patients who were treated for 38 weeks with extended release calcifediol or Rayaldee. These were 78 patients, but their PTH was still above 70 picogram per ml. So we randomized those patients into 2 groups. One group only had Rayaldee, continued on Rayaldee, and the other group was continued on Rayaldee, but we added active vitamin D analogs on top of them, and they were observed for the next 14 weeks. The two treatment groups were comparable with regards to 25D, IPTH, EGFR, calcium, and phosphorus at baseline. And this is just the curve for IPTA change from week 0 to week 38. And then these patients were randomized into two groups. The group which got only Rayaldee had a further decline in their PTH by 2.2%. But the group which got active vitamin D analogs on top of extended release calcifediol or Rayaldee, they had a very abrupt, precipitous decline in their PTH of 35%. And what this transpired into is that the group which received active vitamin D analog had a 11.8% further decline in their GFR. And this was counterintuitive because the hope was that the group which got active vitamin D analog and PTH was reduced, these patients would be able to sustain the benefit of maintaining their GFRs. But what we saw here was that there was a significant lowering in GFR as compared to the group which was on Rayaldee only. And we thought about what could have led to this, and what we saw was not surprising. We saw the group which got activated analog had an increase of 0.40 ml per deciliter in their serum calcium. Serum phosphorus rose by 0.27 milligram per deciliter, and their FGF23 levels increased from baseline to 49.1 picogram per ml. Various trials have shown in the past that serum calcium, serum phosphorus, and serum FGF23 alone are combined, maybe nephrotoxic, but this is the first time we are actually showing this in a randomized clinical trial. So in conclusion, adjunct active vitamin D analogs enabled 35% or more IPTH reduction, but had untoward effects that overrode the nephro-sparing impact of IPTH reductions achieved with Rayaldee alone. These findings support the 2017 KDIGO guideline that AVD should not be routinely used in non-dialysis chronic kidney disease patients. I'm going to stop here, and I'm going to ask you any questions if you may have.
Thank you, Dr. Ashfaq, for your excellent presentation. Before we move on to our next presentation, I'd like to ask you a couple of questions. How did this medication fill a void in the current treatment options for secondary hyperparathyroidism for the CKD non-dialysis patient population? And what does that mean for patients and care options?
Yeah, so I had touched briefly on this during my presentation. So one of the things which I discussed that the current treatment options, or the options we had before we brought Rayaldee into market, were only two: nutritional vitamin D supplements and active vitamin D analogs for the treatment of secondary hyperparathyroidism in patients with chronic kidney disease. We discussed the limitations of nutritional vitamin D, especially in patients with advancing chronic kidney disease and in patients who are relatively overweight or obese. We just cannot raise the 25D levels high enough to lower the PTH. Now, active vitamin D analogs are good drugs in lowering PTH, but they come with a price, and the price is that they can raise serum calcium, they can raise serum phosphorus, they increase FGF23, they may actually contribute to vascular calcifications. And as you know, vascular calcifications are probably one of the most important and grave reasons of morbidity and mortality in patients with chronic kidney disease. Now, Rayaldee fills that void very nicely because it raises the 25D level high and high enough, and as high as you can imagine. It can also lower the PTH very effectively, and it does not impact serum calcium and serum phosphorus and FGF23. So this fills the void very nicely, where KDIGO in themselves say the effectiveness of nutritional vitamin D is unproven, even though the drug is around for 30, 40 years. And they clearly mentioned that active vitamin D analogs should not be used in patients with in patients with chronic kidney disease stage 3 and 4 routinely. They are only indicated to be used in patients with advanced severe stage 5 kidney disease. So So that's what it is. That's how it fills the void.
Dr. Ashfaq, as we move through the final 5 years of the decade of the kidney, we've seen meaningful progress in kidney research and advancements in available treatments. This type of innovation is important to patients. Can you express the importance of why patients, in consultations with their healthcare professionals, should have access to choice and of what treatment, whether established or new innovation is right for them? Essentially, the right treatment at the right time for the right patient.
So thank you so much for asking these questions. This is probably one of the things which is most dear to me, and I'm going to answer this from a drug developer perspective, a nephrologist, 30-year in nephrology, a patient and a patient advocate perspective. This is a golden age for nephrologists. I have never been that optimistic with the current innovation and the new drugs which are coming out in the market than ever before. In last several years, we have seen medications for treatment of diabetes and non-diabetes, which slow down the progression of kidney disease, impact mortality in a better way. Treatment for resistant hypertension, newer drugs for IgA nephropathy and other glomerular diseases, and medications which are being developed for management of metabolic bone disease. I always say this, and I'm going to say this again. We as drug developers can develop as many drugs as we want, the most effective drugs, but if we cannot get those drugs in the hand of patients, what good they do? Nothing, right? So one side, we have to continue to work on developing the best drugs, which can lead to good outcomes, better outcomes, but also find a way to get those drugs in the hands of our patients. So that is one of the things which I think needs to be done. Right drugs for the right patient at the right time. I always say this, all those drugs which are being developed are not going to work in 100% of the patients. Some patients will progress. We all would like to see a world where there is no patient on dialysis, but that is not practical. So as long as we can develop drugs which can slow down the progression of kidney disease, and when they develop chronic kidney disease, which we can control the complications like treating the secondary hyperparathyroidism with extended release calcifidiol, I think we are in a better shape. And I would like to again close my remarks by saying that we need to change that trajectory where chronic kidney disease has risen from number 16 to number 5. We need to change that, and I think we can.
Thank you again, Dr. Ashfaq, for your thoughtful responses and for being part of today's important session. We are grateful for your participation.